Hey everyone, we're here with Jing, Chief Scientist at Algorand. She'll be doing a talk on bridges between blockchains, and I'll let her take it from here. When she starts talking, can you guys confirm in the chat that you can hear her?
Hello, everybody. Good afternoon, good evening, good morning, wherever you are. So this is Jing Chen from Algorand, and I'd like to tell you something about bridges between blockchains. First of all, not since probably not everybody knows about Algorand. Let me say a few words about what we do, who we are. Algorand refers to both a consensus protocol that we designed and our public blockchain network that has been launching since last year. It's we consider it as an alternative public blockchain because we designed it from scratch. So it is not a hard fork of any existing solution, and we developed it from first principles, and we have rigorous mathematical analysis about its security and performance and so on. So this is a little bit about our core technology. Well, again, this is really uh, very quick. If you want to learn more about the core technology, uh, visit our website, and that should be another talk. Today is not about the core technology. So first of all, we are based on our pure proof of stake technology, which means that the user's tokens are randomly selected. All tokens have the same voting power, which is important. So there is no mining pool, there is no dust attack. There is no need to lock up the money in the system, so it's not bonded, it's not delegated. Money always at a user's fingertips, and the assumption is that most money in the system is in on his hand. Here, most money means 2/3. And there's no need to punish users when wrong behaviors are found. Because we can prove that as long as most money is in on his hands, adversary cannot do harm to the system, even though he can say double vote and so on. The more concrete approach is that we run our consensus protocol based on Byzantine agreement via a sequence of ever-changing committees to be safe against dynamic corruptions. And the committees are about, you can think about it as 1,000 users randomly and independently selected each round. And when selected, a user need to send a simple short message and does not need to send anything otherwise. Oh, by the way, I forgot to mention that if you have a question during the talk, please send it in the chat and I will answer them during Q&A. Thanks. Okay, this is pretty much what I like to say about Algorand technology. And in terms of momentums, we have gone through a very active development phases, and a lot of things, a lot of features have been built. Now the codes are fully open source, and testnet and mainnet have both launched last year. We have a lot of developer resources on our developer community website, SDKs, other useful tools, and so on. We have gone through two significant upgrades ever since, and the most recent one just happened in this August. And during the upgrades, we added several important features into layer one, such as user can issue layer one tokens and assets, and we now support layer one smart contracts and other features as well. And we are having a deep roadmap with more innovations to come. Okay then, and in terms of today's tech material, I'd like to focus on smart contracts, how we think about it, how we designed it, and I'd like to say a little bit about interoperability, which is going beyond just Algorand. And because we believe in a multi-chain world, I think both are critical building components for such a world. As I said, smart contracts is not just important to one blockchain, but it's really of common value to everybody. It captures value from the classical finance world, and it is opening up the active DeFi world that nobody has imagined maybe 10 years or even 5 years ago. And just take a quick look on Google, you will see that you know ever since early 2020, the amount of assets locked up in smart contracts have exceeded $1 billion in the DeFi markets. This number has gone up a lot recently, but I couldn't find a consistent number. Some says 2 billion, some even says 10. You can find the articles on the website, but it's easy to get a sense that the market is growing a lot. And this is largely driven by the development of smart contracts, not just on one single blockchain, but on many blockchains. But of course, in the smart contract world, we understand that smart contracts are both exciting and scary. If not done properly, bugs and active attacks can cause huge loss to people. And the most recent event that caught my attention happened not too long ago. With a project that crashed basically on day 2 of launching due to some bug in the code. And there are other problems too. I would say that the next problem is probably a good problem to have, which is because smart contracts, particularly smart contracts on Ethereum, have gained so much popularity. Um, we see a lot of congestion and the fees have gone up a lot. Definitely, this is a problem we need to address, but this is something good to see. Okay. Um, from my perspective or from our perspective, various smart contracts problem can be attacked from many fronts. uh, Different aspects, we can address at programming language design, which is a very important community in the computer science literature and in the industry, where Blockstack and have definitely have a lot to say, and the Algorand is joining this is joining forcing. And also another front that people probably did not think that much is about the smart contract architecture, which I'll also say a little bit. And formal methods and system security, there are many different fronts where this problem can be attacked. So I'll start focusing a little bit on programming language, and as I hinted, we are very happy and excited that we have joined forces with Blockstack to adopt the smart contract language called Clarity um, in our smart contract system. And of course, Blockstack is building Clarity in their system. I think this is a very promising event where two major blockchains are joining forcing on this front. But you know, without giving you too much details about the exact language design, I'd like to zoom out a little bit and discuss a little bit about what kind of language and VM from a high level do we want at Algorand when we started thinking about our smart contract solutions. We did not want to reinvent the wheel. We understand very well that the programming language community has been working on such things for a long time, and there are lessons to be learned and there are experiences to be taken. Um, but we did a lot of survey and we converged our own principles about what things that we care about. To give you a small list, this is not thorough but representative. We want our language to be human readable and have modular structure so that developers would have easier time to think, to write in them, and to design their applications. We want our language to be interpreted, not compiled. This is because of two things. A, we do not have a compiler, so we have a smaller trusted base and one less place where problems could happen. And another important realization is that computation time is not really a bottleneck in the system. Even for a blockchain, as fast as Algorand, where we have 4.5 seconds per block, um, the network and the block generation time takes longer than the VM's execution time. Of course, with compilers, people can do all kinds of optimization tricks, but with interpreters, we already see good performance that is enough for the smart contracts on blockchain. Also, we want the language to be strongly typed, with type inference, because we definitely see attack vectors on existing smart contracts where ambiguous conversions between different values into different types have caused the problem. Um, Probably not surprisingly, we consider security or safety as a top priority, and we want to have built-in security features in our language. For example, currency cannot be created out of nothing, cannot be destroyed all of a sudden. So such security features should be built in. And the static dependencies, no dynamic dispatch, or are probably restricted dynamic dispatch. And another thing we want to highlight is that we want the language to have easier time to estimate the execution cost. This is for users or contract callers' sake, so that people will know ahead of time how much he's paying for his contract call. This is not an exhaustive list, but you can get a sense about what we care about. And with those principles internally converged, we did a pretty thorough literature review about what is available in the domain. And we found the clarity, and we are very excited about, this is a language sharing a lot of the design highlights with us. And also it actually from the development perspective has a good prototype system that we can quickly try on, and which is very important for us to deploy our smart contract architecture. So there are a lot to be said about the language set alone, and I can go on and on for an hour. But for this talk, let me stop here for the language and say a little bit about the architecture part. Um, for the architecture, the first I want to do is to make a important conceptual separation that the consensus protocol for block generation and the VM execution should are two separate things. They could be done by the same group of people or machines, but they do not have to be done in that way. In particular, we have seen Ethereum as the first and the most successful and most inspiring smart contract platform. Here, the VM is executed by the same miners for block generation, hence what we call layer one. But it does not have to be that way. In particular, we looked a lot of many of the existing smart contract applications. We realize that not all contracts belong at layer one, and there is a long tail of applications that would rather they do not block everybody and they do not sit on our critical path for block generation. For example, applications that are too big with a large database, maybe security offering with a database of whitelisted investors or blacklisted investors, or computations that are too long. You can list many cryptographic applications like ZK snarks and elliptic curve bilinear pairing operations are in this category for sure, and many others. Applications that are too weird, sort of. They're nice. They are a lot of fun to play with. But they come up as all over a sudden and disappear all over a sudden. The layer one would not have the time to respond to them. and actually CryptoKitties crashed Ethereum in the past. So this application is probably better than in layer, not in the critical path. And the application that are too complex, that needs certain modularity for software engineering purpose, they may decompose into multiple contracts. Different contracts may be managed by different accounts, and those accounts may not trust each other, and so on and so forth. We consider smart contracts, those complicated smart contracts, probably for skillful developers, not really for muggles. Let me put it that way. And those probably better fit not in the critical path as well. So our approach here, um, first, we have simple on-chain solutions for simple problems. Here we have a very simple script language in layer 1, designed to be simple and restricted. But simple problems do not mean they are not important. Actually, we look at many applications and realize they do not need that complicated a logic. Like we can do auctions, collateral, crowdfunding. Many of those can be directly done in layer 1. This is a assembly level language. I do not think many developers will be able to write in it. And then complex user-defined computation would be put out of the critical path and would be executed by the VM speculatively. Now, since it is speculative, it is important that we have layer 1 structures to make sure the effects are installed in an atomic way, that a contract may have 5 transfers as a consequence, and all of them have to happen atomically for correctness. And this architecture, I'm not going to dive into it, but such an architecture is pretty much VM agnostic, which gives us great flexibility about how to design the VM and which language to choose. And not just the VM has flexibility, but this design of the architecture can also be adopted in different blockchain architectures, as long as the blockchain has the necessary layer 1 structures, for atomic transition, predicates for, precondition checking, and so on. Then this can be applied there as well. It doesn't have to be a public blockchain either. So this is our approach, and I will just mention that for formal verification, formal methods, we also have our partner random verification, which is building a formal semantics for our programming language. Okay, I think I spend a lot of time talking about the smart contract solution because it's very important. And I'd like to talk about interoperability, which is another thing I think would be critical for the blockchain economy's success as a whole, not just for a single blockchain. We see a lot of solutions in terms of how to connect different blockchains. For example, token bridge, right? That allows token to be transferred between two different blockchains. It's largely a burn and mint solution, where certain tokens are burned or locked in one blockchain and minted as a new token on a different blockchain. Particularly useful for stable coins where the tokens are matched to real dollars, and we definitely want to keep the total amount at a fixed level rather than, even it is crossing different blockchains. But also, it's also fair to say that token bridge is still at a very early stage. We see experiments, prototypes. At Algorand, we are also building our own token bridge with other blockchains. I'm not going to get into it. Just to warn people that at this early stage, there are many unsettled issues with the solution yet. It's definitely more complicated than just a simple burn and mint. For example, we have seen projects broken after 2 days, and there are many security and privacy issues to be considered for this front. I want to mention briefly our co-chain solution, which is multiple blockchains within the same Algorand ecosystem. that a cochain is an independent chain that is attached to the Algorand main chain, but is independent and manages its own consensus. From the outside world, it looks private, and from the inside, it is transparent to its own users. Different from a token bridge, it directly attached to the Algorand main chain to interoperate with other cochains so that there's no burn and mint. And the main chain provides automaticity and security guarantees for such cross-chain operations. Pictorially, it looks somehow like this. Say we have the blue token and the red token on their corresponding chains, and they want to swap. And the swap would happen on the main chain, so they first transfer to the main chain, and the main chain within one step would transfer to their corresponding co-chains. And the co-chain now would have their token swapped as desired. So this is atomic, so that one chain cannot cheat the other chain to get both tokens. Um, the quotient structure will share the same features as I mentioned. For example, the smart contract architecture, the programming language, the VM, but it also brings great flexibility in that different cochain can even set up their own VMs to focus on different applications. For example, it is likely to have one cochain focused on financial applications in their VM, and another cochain focused on data management applications, and another cochain focused on privacy-oriented applications. They can all have their own smart contract architecture and their own VM. So that gives us also big flexibility. Um, Finally, I'd like to say a little bit about smart contracts across blockchains. I got asked by people a lot about, whether different blockchains will have their smart contracts compiled to each other back and forth. Um, in my mind, when when a contract mitigates to another contract, of course you have to compile to the target language. But since we believe in a multi-chain world, we believe there will be multiple blockchains with their own smart contracts languages, um, all running together, such as Ethereum, Blockstack, Algorand, Tezos, etc. There could be many of them. Um, in order for them to have smart contract across blockchains, of course, I would imagine the languages should share some common principles, some level of modularity, certain security features, etc., with the language somehow being compatible with each other. Um, and An important thing I'd like to highlight is that people may not need to transfer their code back and forth all the time. Um, an interesting way we are exploring is efficient and safe way to share data crossing chains so that the contract code can access data, from Ethereum on Algorand, from Algorand on Blockstack, from Blockstack back to Algorand, and so on and so forth. Um, as long as those data and contract states can be shared, the codes may not be shared or copied or transferred all the time. That may be a easier way of doing cross-chain code. And there are many privacy and governance problems to be answered. For example, we even considered legal issues like, if some token got put into escrow on Ethereum and mapped into Algorand, and later got transferred out of the escrow by accident, what's the implication of that event on Algorand's corresponding tokens, so on and so forth. So those are more than technology, it's also governance, policy, regulation, and so on. So there are many different fronts to be explored in this largely open area. Now, um, wrapping up, looking into the future, as I said at the very beginning, we believe in a multi-chain world that a lot of successful blockchains will coexist. And I believe smart contracts are of common value to all, uh, not just a single chain, but this is really a large financial and DeFi world. And interoperability is a key to the success of the entire economy as a whole, not just a single chain. And as we have done, and we are going to do more, we're really excited, and we really believe that the multiple blockchain projects should join forces to build a real technology to realize the full potential of blockchains. This is a world too big and can host multiple good blockchain projects, and we should work together. So with that said, thank you, and I'm happy to take questions.
So there are some questions in the Ask a Question tab at the bottom.
Right, I'm going scrolling up to look at the questions. I'm a little bit slow. Um, Somebody mentioned complexity is currently a barrier for blockchain apps. It's very important to provide users with a flexible experience. I completely agree with that. It comes in multiple folds, from the design complexity to the execution cost. Um, Both need to be thought of. How to make it easier for, we have a good software engineering lessons from the industry, and we also have, hardware design and other optimization skills we have that we can learn from. As I said, we come from academia and we learn so much from our colleagues, and we know we do not need to reinvent the wheel if there are good people to work with. Somebody mentioned, hey, my buddy was one of the first CryptoKitty buyers. Um, I want to echo that because CryptoKitty was my first crypto asset. I didn't reach this the crypto world through investment. I approached it through a research experience. So I didn't buy many crypto assets or tokens, but CryptoKitty was something that got my attention, and I had that. Do we still have time?
Yes, you have 3 more minutes.
Okay, another question is how is Algorand currently using or working on the Clarity smart contract language at the moment? Any plans or roadmap? Yeah, let me say a little bit. We're taking there are two components. One is the Clarity language itself. One is the VM's connector to the Algorand blockchain and the Algorand smart contract architecture. The second part definitely is unique to Algorand, and we are building that part ourselves. How the VM issue Algorand transactions and how to read from the blockchain and so on. Um, for the VM side, we are collaborating with Blockstack, um, you to use and adapt Clarity. Um, we have features that we'd like to have, and when the two teams sat together, we realized there are common features, like Clarity is still growing and evolving, and we figured out that there are features we both want, and I hope those will come into the system. Like we would add those features in our system. Of course, we'll make it open source, and people can use on Clarity. And when it is added to the Clarity language, we can get that into our system as well. So I think the communication is fairly smooth, and there are a lot of common things we can do.
Hey, Jing, would you mind dropping in some way for people to ask you questions if you aren't able to answer everything within the next 2 minutes? Like, do you have a Twitter handle for people to DM you or follow you or an email?
Do we
Or
still
just,
have this room? If we can have this room, I can stay.
no,
Uh,
it doesn't work like that, unfortunately, for
okay,
Crowdcast.
sorry. I think we have Algorand channel, and If you ask questions on Algorand channel and the Blockstack's channel, I'm sure that can be related to me. Unfortunately, I'm not that fluent on social network.
No worries. Okay, cool. So I believe the channel the link has been dropped in the chat. If you have any like closing thoughts, we have 1 more minute.
Pardon?
Do you have any closing thoughts or anything else you want to say?
I'm excited to present our work in this community. I understand that this is people enthusiastic about smart contracts. That's great, and I do think joining forces is important for the blockchain domain. We see so many projects, and the domain is so big and so complex. We do not expect a single project being able to solve each single question, each single problem. So I would encourage people to start collaborating and talk to each other, and that's what we plan to do more in the future.
Yeah, that's fantastic. All right, we're going to transition to the next talk now, which will be between Blockstack and Chainlink. Thanks so much. This is really great.
Great, thank you.